Hey guys, welcome back. I'm fresh to this, as you can see, so it's going to take me a bit, but bear with me, it's good fun. Alright, what we've actually got a major drama with my own particular car of all things. It runs a Wolf V550. It has a MSD cam and crank trigger. Now, the problem is we keep losing our trigger signal. And it's off the camshaft, which is your sync, as it's called, a synchronization. So that way, because this thing runs sequential injection. So because, as you may or may not know, small block Chev don't run a retainer for the camshaft. They do run cam buttons, however there still is thrust. The only thing that stops the camshaft from moving back and forth is this gear here, which is crazy. So we keep losing our trigger reference, our trigger point, and then all of a sudden the car just conks and then doesn't start, then it finds it, then it picks up, away we go. So we've gone, okay, bugger this is too intermittent, it's scary, because if you roll on throttle on the street and then back off, thrust changes, and then bam, signal's gone, you pull over, you got to wait everything to settle down, and then you're away again. The second drama we have with this car is it's got a recessed firewall, and I've pushed the motor back 230 odd mils, and it makes it really close to get a distributor in to what firewall is left there from factory. We have roughly from the base, I'll use this one because this is off a small block Chev, where the base of the distributor bolts into the manifold to the top of the firewall is about 120 millimeters, I should say. That makes it really tight, So I've got an old distributor here. This is an A cell, and it is set up for Hall effect, which is what we want to run. This is a dual Hall effect. The sensor and everything I've changed, I've modified this, and this is out of a VT Commodore, which is your 5 litre 304. So what we're going to do, we're going to shorten this distance up here. It's going to be very tight, and just have enough for the retainer to hold. Okay, so we're not going to be using this distributor cap here, which is your factory A cell. This is probably about 100 mil on its own. What I do have is this brand new VT dual Hall effect sensor distributor. So what we were going to do is pull this apart, machine this up, and mount it like so, with the factory VT cap, which is nice and short. I think, look, going by rough measurements, is about 90 millimeters, which is going to be extremely tight, but it will give us enough room to do the job. So follow the journey. This is going to be good fun, good content. You'll enjoy this. Okay, first things first, we're going to have to remove that high tension pin. We're just going to put it in the vise, get a pin punch, like so, and we'll just tap him out. Small block Chevrolet, oil pump, Holden 308, no oil pump, as the Holden 308 runs an external pump. Same technique on the humble Holden V8. So we'll knock out the high tension pin, then we can start disassembling the internals of the distributor. Okay, we're going to tap this out with a copper rawhide. It's actually really tight in the body, and we don't want to damage anything. There we go. Okay, we might have a change of plan. I've noticed that, if I can get the right angle, there is a high tension pin holding on the chopper wheel, if you want to call as such. So what I might do is knock that out and then pull that out. The shaft's being extremely tight on that bronze bush. There we go. Okay, so this should come out now. Beautiful. So we want to stay with our sequential setup. We have our ref and sync, which will be on our ECU. Okie doke, not what I expected. It has a bearing there, so that was hitting the base plate for the pickup. It's actually bent it a little bit. We'll fix that up. I was only expecting a bronze bush in there. So there we go, I flattened that back out. What I did was reassemble it back in the body. Reassembled it, screwed it in, re-tapped it back down. I should have probably been aware because of this big boss area right here, but I wasn't expecting there to be a roller bearing. Anyhow, we got away with it. So the ACL distributor, we're going to disassemble it. This one here does run a bronze bush because I have done this conversion before. Idiot. So there's our shaft. We'll actually retain and use this shaft because it's got the pump drive on it, but we will remove this top paraphernalia. Phillips screwdriver. That's him, he's out. Okay, as you can see, we've got Allen head cap bolts, and that retains the top part. So obviously ACell have a few different tops, and they just bolt that on. Okay, so what we got, they would do this on a CNC, machine center, and they do this PCD, including the base for the distributor. What we're going, I thought, beautiful, we could clock it up on the mill, do the PCD, and bam, we could re-bolt that back on, but we're not going to be able to. That's the reason why that shoulder section's there. So what we're going to do is basically carry through that diameter all the way through to here, because this will be solid aluminium or aluminum. And then we'll just sink this down, and may have to give it a tack with the TIG. I don't know, I'll see how I go, because this is already to size. I might turn this section here as I machine this down. I might make this a couple of thou bigger, so that way this is like a press fit and that stays on there, and that way we don't have to give it any heat from the TIG. See how we go. So what I'm doing, it's very hard to get a register to make sure this is running true, and I want this to run true. It has to run true. So what I'm doing, I'm turning around the tool. I don't know what the fuck this is called, to tell you the truth. So they do these in quick releases, but I'm turning that around and touching it and spinning by hand just to take out any of the wobble. You could use a dial indicator, no need to for this. So very roughly, we've got about 8 mil, which is plenty of flange for us to bolt the new body onto. Ooh, yeah, she come loose a bit. So what we're doing, we're changing tools. This gives me a much nicer angle to get in there. What I'm doing, I'm giving it a rebate or a register, if you want to call it, so that way everything runs nice and true. Respectively simple, we're just dealing with circles. Okay, bit of a recap. I do apologise, I ran out of battery power. Gonna happen. So, our body with our register. This is our register receiver, which is our billet small block A-cell distributor body. And as you can see, if I can do this correctly in the camera. There we go, she's in. So, I'll come up nice and close so you can see this. That's better. Oh, there's a bolt hole. So you see how much of a tight fit. This is actually on size, so I've made it so it will spin and I can get the orientation correct, but it won't press in. It's not a press fit because we want to be able to spin that around and get that in the right rotation for our distributor cap. Okay, the next bit. This is our small block Chev A-cell body. As you can see, I've turned this down. And it is a press fit, and we're going to press that into the original base. So as you knew, it was screwed in. We're not going to have provision for that, unfortunately. It's a press fit. Shouldn't need any Loctite. I will be Loctiting this one, probably 6:30 I think, once this goes in and into place. But we'll also be retaining it with the Hall Effect base plate, and that will retain and basically sandwich these two together. So once we've got A, B and C, we will have to remove the bush, and that's the bronze bush for the shaft to run on, and that will get pressed into our new main body shaft or main shaft. So we're going to press these two together. I've had a look-see, it doesn't really matter the orientation. So here we go. You want to press the button? Go. Go. Stop. Excellent. We'll do the rest by hand. Perfecto.
How did it get in there?
Magic, 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 magic. Okay, so what I've done, I made a little tool here to push the bush, which just so I can't see. Double assembling here. Okay, so I made a little tool to press him in. That's done. I'll put it with the tools. Okie dokie, so as you can see, this is the body. I'm hoping I've got enough room here to put the retainer in. It's going to be tight. That's all it is. It's going to be tight. This is the main body of the Dizzy. I might, depend how it wants to sit, I might still have to do a bit of trimming on the firewall. I'm not quite sure yet. We're going to see. I don't want to. I might have to. So as you can see, the register, there's basically our Dizzy, and I can spin this to where I want. Now, to make it functional, the Hall sensor, the body of the Hall effect sensor will screw in like so, but it'll also screw through and retain this section. So we're probably going to drill them two out and make them larger because it actually holds the body of the distributor in. It's going to be tight, and that's the scary bit. Here's Namisha. Yeah, so let's see how we go. We're just going to progress. The painful bit is to actually put this in the car. I have to semi-remove the motor.
In the car?
In the car. We're going to put it in the car. I have to
Customer?
No, customer's car, daddy's car. This is for my car, the green one. So I have to remove this from the car. Sorry, I have to move...
In the green car?
In the green car. I have to remove it from the motor, pull the crab cap out, then slot this in, and then put the motor in. Hopefully it works. Hopefully. Okay, day 2, we're doing the conversion here. VT Commodore, dual Hall effect sensor, and that's obviously our Hall effect sensor there, I should say. And this is our small block Chev. We've pushed for as much room as we can. We're squeezing a heap of room out of this thing. So, excuse me. Lo and behold, there's 2 holes in this distributor, there and there. I've tapped them. They've been drilled out all the way through. Now basically all I need to do is line them up like so. Then we're going to screw in our Hall effect sensor. Phone's a little bit high. That's okay. In the right spot? No, we're not in the right spot. I wanted it there. That's a bit better. There and there. It seems to want to work a little bit better. Okay, do I have? Probably not. Allen key. No, because they're imperial and that's metric. Always get your... Okay, we'll get our sexy little snap-on ball end Allen keys. There's our cap bolt. Cap screw as they call it when I order it. What do we want? 3mm. Yep, 3mm, there we go. This is actually a M4 by 0.7 I think, or 0.75, something like that. Go straight through there. Now this is going to be tight because half the hole has been machined out via the lathe. So getting it started, there we go, that one's nice. This one's just a little bit funky. Here we go, there we go, there we go, there we go. Now we're winning. So there we have it, there's our body, that's assembled. There's our screws poking through the bottom. And you can see how tight this is for room. This is going to be extremely tight. Okay, so what I've done, I've machined a groove, as you can see, and what that will do, that will hold a little circlip and a washer, and that will stop basically the shaft from dropping through. The gear on the camshaft and the drive on the oil pump, you can't rely on that. You're going to have to hold this in the correct spot. It is going to have some backlash, but not much. So that washes on. That there. That's our washer. Basically, all these parts here were out of the original A cell and the VT. So all that we already had. Okay, and just so by chance, that's a really good fit. As you can see, she spins around. That's what we want. So I'll try and get that closer for you to see roughly how much play we've got. So I'll get that a bit better. I could measure that, but I know that's going to work fine. Okay, I'm guessing, look, at it, maybe 40 thousandths. Let me see, I know these rolls are 40 thou. Yeah, probably about 50 thou sort of thing. Very rough. Okay. The next bit, we'll reassemble this to make sure it all clears. Should we do 1,000,001 dummy assemblies? That's that. Okay, so as you can see, there's our Hall effect sensors. Drop our chopper wheel on, and we won't commit to the chopper wheel like I said before. Let's drop down a little bit too low, but that's okay. We will do something about that. We don't want this to be permanent because as you can see, it's not spinning, but we don't want this to be permanent because we need to set this at 60 degrees like I mentioned before. Can't use that one, he is way too big. A little bit tight, but that's pretty good. And it won't come out. There we go. So you can see there's the E-clip. That's basically for the chopper wheel to sit on. That's all it is, just for assembly. So he will go on like so, providing my measurements are correct. But this is the painful bit. Everything is a dummy assembly to make sure this works. You can only get so many measurements, and then basically you got to do what you got to do, machine it, and then assemble, make sure it's correct. Because we're making a one-off custom made, if this was in mass production, then it'll be a hell of a lot easier, because basically you've just got a whole bunch of drawings, you set the machine and away you go. Let's see how that went, because I think it's going to be perfect. Yeah, thought so. Thought so. So that's okay. Okay, my measurement wasn't quite right. So, we're shaping up pretty good. What we do need to do is get that height right. Oh, let's try and get it in focus there. So it gives us a good idea. I think it's a 17mm and 17mm, really funky. But we'll do another dummy assembly. Okay, it was fighting me. We had a problem. Like, I stopped filming for a moment because we had an issue. The Hall effect sensor now wants to spin. It was very, very interesting what was happening. Can I get it with my nails? Oh, just got it. So, come on. There we go. Ah, look at that. So, it's spinning now. We're back on course. So what was happening, I've put some washers there. That literally is just for assembly, because we're going to tack it and that's going to be held there. So, however, the problem was, pull him out. The problem was the inner chopper wheel with the inner Hall effect sensor was colliding, and I thought it was colliding with the plastic retaining plate here, and that retains the wires so that way they don't get caught up in the disc spinning around. It so happened the inner chopper wheel was collecting the inside of the Hall effect sensor. So then I had a look, you can probably just see those marks there, right there. So what I've done to correct it, I've just angled it out. I grabbed a pair of multis and just leaned it out, and now it's not interfering with it. I changed these around, I switched at 180 just in case I had it wrong, didn't, because as you know this can spin around wherever it wants to be. But yeah, it's fine now. I won't put that back in because that's a menace. So the next thing we need to do, we need to drill a 9mm hole there, and then we need to cut a slot in the milling machine. So yeah, welcome back.